Hi, Daniel. Welcome back.
Hi, it's great to be back.
Yeah, after all these years, right?
Yeah,
I actually forgot when you were here the last time. You remember?
I think it's a year or two. I have
I found it. This is the episode number 120. And this was in December. Oh, December
2020.
28th, 2 years ago.
Okay, time flies.
Time flies. So, you're still working on Helidon, I guess.
Yes, I do more
Yeah.
and more.
So, what happened in the last 2 years? Except, some Java doc formatting and,
A lot.
So, okay. So, what are maybe how to start this? So, what are the most remarkable or exciting features you are working on?
Well, the most exciting is the NEMA, of course, because it's the virtual thread wave we are riding on, and it's great because the Java 19 came out finally with the preview feature of the virtual threads. So finally we can show off some of the work we have been working on, and it's great. It's great because finally the programming isn't that reactive anymore, and it's kind of fun again because you don't have to debug everything that carefully, and it's the stack traces aren't so scary anymore, and everything gets much faster. So it's great time. Well, it's great time for the Java developers now because there is a lot of new features, and the JVM is getting better and better.
Yeah, this was always my strategy. I completely ignored reactive programming and waited until something happened. So now it's the time.
Well, yeah, you missed a lot of fun, actually.
Yeah, I was in some project, they used a reactive style and then asked me how to debug the stuff. So it's always fun, because even, I don't know whether you remember the old GMS days, they were not that reactive, but still, messaging was always challenging to debug and to find out what's going on because there are lots of, messages passing along. But NEMA, what it is Helidon on virtual threads, right?
Yeah, but it's not just like, switching from some way to the other. We have completely bypassed all the reactive and asynchronous code from the socket up. It's the web server which is completely blocking, which is cool again to block. And because of the virtual threads, it has the same speed, even faster in some use cases. It just hides all the complexity of this, of all the things you got from the reactive programming. It's hidden from you now because this machinery which does this magic is something you don't have to care anymore, at least not that much. So you can concentrate on your business code and
yeah, but I never cared because the problem is all the application servers were fast enough, but I suspect with the NEMA is complete different different league, so different order of magnitude which it can actually handle, right? So I could write with NEMA, I guess, something like a load balancer, which would be harder to write with regular application servers, right? So this would be one of the use cases.
Well, I think you could write it with if you took a green netty and did really one purpose only server which would do the load balancing, you could get to the same numbers, but it will be much harder. You need to know much more about the low level stuff, and then you could get to the same numbers. But with NEMA, it's really like a few lines of code, which is not really complicated to understand. And if something goes wrong, you just throw exception instead of figuring out how to pass the error to this reactive pipeline and when happens what and how to synchronize or not synchronize something. So
So it looks like Java in 1995, right?
Yeah, we are getting back. We are just much faster now.
Okay. Why the name NEMA?
It's another Greek name because we got used to it with Helidon. So we used another Greek name, the Nima. It's I'm not sure what does it mean. It's something with darting. So now we have this sparrow which is darting really fast. So it's Helidon Nima. We had some, like internal project name before.
Yeah, what was it?
Yeah, it was Warp because
Warp, okay.
it's part of this looming machine, So
Okay.
with loom and virtual threads, it's kind of fit it in. But then we figure out there is another web server already called Warp, so we started to look for different name, and we have been voting, and there was several options, and then we came with the Nima, and I think it fits with the Helidon, so it's all has this Greek sound.
What's interesting to me, of course, is can I use my boring Java EE microprofile code, or do I have to use with Nima the specific handlers?
We are working on integration with Jersey. So in the end, it will be just Helidon MP on top of the Nima. We are just getting there very carefully, so we don't lose much. When we have so much performance, we don't want to lose it just by adding some abstract layers. So we are being very careful now, and we are trying to find out the best possible way how to integrate it. We have some working POCs with the JAX RS, so you could, but we want to make it even faster. So because of this abstraction layer, you lose some of the performance.
Yeah,
it's
sure.
inevitable. But we are trying to lose as less as possible. So we will get there. We are just working on it right now. So now it's Nima. The Nima is not finished yet. It's still alpha release. The really finished part is the HTTP 1.1 with pipelining, which is finished and it works perfectly. We have a server and a client, so you have both sides. And now we are working on the HTTP 2, which already works. We are still fine-tuning some flow control and those things. We will also have the client for that. So there will be, and it's really fast again. So it's really nice because with the current implementations of the HTTP 2 are somehow not in the spotlight lately for some reason. I don't know why. Even in those famous benchmarks, they are not really benchmarking the HTTP 2 for some reason. So we are trying to be also fast there. So when the world moves finally to the HTTP 2, we will be super fast even there. And we have the WebSockets implementation. It's prototype so far on the server side, and gRPC, that's also prototype yet. And we already have a tracing and static content support and health and config and fault tolerance and all those things we in the end need for the Helidon MP. So we are moving there. We are just being careful so we don't slow down on the way.
So this would concerns me a bit because I don't have to use the reactive APIs, but if I had to use strange Nima APIs, I would be even less interested. But what you are saying, we can rely on Jersey or JAX-RS on standard microprofile APIs, and behind the scenes, Nima will just implement this, which is for me, of course, great news, because I can just reuse my old boring code and run it faster, or I don't know, faster, maybe more scalable, right? So this is about scalability, not necessarily about speed.
Yeah,
right?
you will be able to start less pods, so it will be cheaper, of course. There are things, it will be a blocking code, so you can take your old proven code and run it on the new. When we have the MP version, you can run it on the Nima-based Helidon. But there are some small differences. For example, because the whole virtual threads are the huge abstractions which is hiding all the complexity of not switching context between the platform threads. So there is one thing when you need to be careful, and that's obstructing those virtual threads. That's kind of like everyone is talking about it, that the virtual threads are having a problem. It's not a problem. It's a feature.
What's the problem, or what's the feature, and what's
you can
what's the issue?
actually yield on the virtual thread. So you can, if you have some really CPU heavy operation which is blocking your thread, which is obstructing your thread. They have in reactive programming, they have even word for that. It's called obstructing. And in the spec, it's written you shouldn't do that on the reactive pipeline because otherwise, you will obstruct the thread of the native, for example, of the event loop, and then your server will stuck and won't respond to requests. And the same apply to the virtual threads. If there is some CPU heavy computation, some batch work which you need to do, you just need to offload it to the platform thread. And to be honest, if you have been working with the reactive code before, it's the same thing you have been doing before. You just don't have to be afraid of the blocking, but you have to take care of the obstructing the thread. And that's what we always did. When there was really something computational heavy, you have been doing some work batches and executing them in some queue. So this doesn't change. It's just can worsen your performance with virtual threads.
Yeah. So if I'm, let's say I'm implementing my JAX-RS NEMA application, and then it will block for 10 seconds because I'm waiting for something from a database.
But that's no problem.
Okay.
That's what.
So let's create a problem. So what would be a problem? A problem would be if I would run in a for loop, right? And calculate.
Well, for example, you will be mining some bitcoins or
Bitcoins.
something.
Okay.
For
The
3
Bitcoin
hours.
miners is a problem again. Okay. So let's
then,
say.
Then you would actually be standing on the one physical thread. So there will be one less physical thread in your server. But if you would have a web server which would be mining bitcoins based on each request, then if you would have a 3,000 requests, you will kill your web.
Yeah, sure. But it's always the case.
VM.
It was always the case. So what I'm just trying to understand. So let's say I would just mine Bitcoin in a method like get Bitcoin. So this can take forever. So what will happen with virtual threads? They are bound at the end of the day to a physical thread. They have to, right?
Well, since you cannot yield, the virtual thread would be pinning the physical thread.
And yielding means, if you tell a thread yield, it means stop and another thread should work.
Yeah,
so
you are basically saying that your work has lower priority than some other work.
Yeah, exactly.
And the physical thread can be taken from you for something really more important, like the event loop.
Yeah.
So that's what you can do right now.
Yeah, but still, you cannot do this with virtual thread. Understood. But what can happen in worst case? In worst case, I get 3,000 such requests and my server will die, right? This is the worst case.
Yeah. At some point, you will just run out of the physical threads. You virtually cannot run out of the virtual threads.
Yeah.
But you can run out of your physical threads. And when it happens, then won't be any other threads to actually respond to another request from your server. So your server would become to be unresponsive. It would run if your memory would be enough, but it couldn't actually respond to anyone else.
Yeah, but there is no magic, there is no solution for that.
Yeah, it's always the matter of clever offloading or queuing the work like that. And it always have been. There is no change in it, really. It's just you have.
Now I understand.
You have to be aware of it, like you always had to be aware of it.
Yeah, we always had to. So this is why I don't even understand the problem, because what we are saying now is we get a new wave of application servers who don't care anymore about concurrency. So it would be possible to have millions of concurrent threads and this could kill your machine, right? This is what we are saying. But in practice, all the application servers had already some throttling mechanism in place, right? So if you apply our own, max pools or a fault tolerance for microprofile, there's no issue at all because we can reduce the amount of parallelism, at the boundary level. Okay, so this is like talking about nothing. If you would use virtual threads naively, then you have a problem. Which is always the case.
If you use reactive streams naively, you are going
to
hit the wall much faster.
What reminds me, once it was at the beginning of the cloud, so someone started a virtual machine. It was in the cloud, the VMware, so typical virtual machine, not Docker, typical virtual machine on a physical server, of course. And the physical servers, I think, had 4 cores, but it was possible to over provision the virtual machine, and they said like, hey, there are 30 cores, the virtual machine, and we run our application server and share the virtual machines, like, why it is so slow? And it turned out that, of course, the virtual machine everything was virtualized, but at the end of the day, a small server, had to handle all the virtual cores. So no magic. So it's actually the same situation. So the virtual threads, there is no yield. If there is no yield, they are pinned to the physical thread. If you are no cautious and you start thousands of virtual threads, this could kill your machine, which was always the case. I mean, even whatever you do, you have always the problem, right? You cannot just, this is like...
there is no escape from it.
No, yeah, exactly. So, this is like, we could talk about this, but this would be like magic. So if we solve the problem, we get a Nobel Prize. I can stop podcasting immediately, right? Yeah, cool. So NEMA sounds... What I like, actually, this is I already told Dimitri in the last podcast, is because, Helidon is somehow close to Java. Because, this is the same team, right? You are working somehow with Java platform team, or at least you see them from time to time, I guess. And maybe with Corona is getting better because everyone is accustomed to work remotely. I guess I have no insight, nothing, right? But so you can fully leverage this, right? So, okay, then let's create, a nice micro-profile application with support for virtual threads. Or the newest Java 19.
We got a lot of help from the Loom project members. There was Alan Bateman and Ron Pressler helping, and Sergei Kukshenko. And they've been actually helping us to find out the most efficient way how to use virtual threads in the web server. And we've got a lot of the performance because of this cooperation. So
for them it's also great because they can validate their concept with a real world application, which Helidon actually is.
It was even that we have found some issues and they have fixed them, and then we could go through this way to get much faster, and it was a great cooperation, actually.
Yeah, this is what I really appreciate, because it's not like moving Java forward, or really. I mean, this is like back in the days, right? And so you are working now on virtual threads exclusively with NEMA, right? This is your NEMA baby.
Yeah, we are working on a NEMA, but we also have the reactive Helidon, the Helidon SE.
Oh, don't mention this. This will die soon, right? This reactive.
But we still have new features in it, and it's
okay.
Still nice. And there always will be the reactive people somewhere. I don't think they will stop being proactive overnight. There is a lot of people who are who invested a lot of time into the reactive code and
conference talks.
Yeah, and conference and we still have the reactive Helidon, and we even are planning some abstraction over the NEMA. So if you will have some reactive library which has the reactive streams API, we will have some abstraction which will integrate with this library nicely. So we will have the reactive API, but behind it there will be Helidon, which will just block and await wherever it needs,
I make a lot of fun about reactive right now, which is not fair, because what I don't like is to use reactive for scalability, because it's often not needed in my project. So I'm not building Instagrams. We usually building smaller, not that scalable applications. But what reactive can be nice is if you have lots of like workflow like application, and the reactive provides you with a nicer DSL, you can say do this first, then transform that. So this could be actually nice to have a reactive. Or we had already the conversation, if you're working with something like Kafka, which is actually reactive because it's like a stream of data, and you react to a stream of data, then reactive programming is just great. Like Kafka streams, which for me reactive, right? Yeah, it is very reactive. So I'm nothing against reactivity, but reactivity works best with reactive data sources, right? So if you have something which and HTTP is not reactive, so it is like request response. So it's not that. So I think virtual threads do great for all micro-profile applications, except micro-profile reactive messaging, which is more like Kafka-esque, integration. So from my perspective,
I think the messaging in general can.
And UI is the same, right? It's a user interface. You can consider the user interface as a stream of events, so you can react to the events and do something on the fly. Another question: there is a new API, or not? I don't know what. Not API, a spec WebSocket streams. You heard about that? This is WebSockets with back pressure. Nothing to do with Java. It's just
I wrote an article a long time ago about integrating the reactive streams with the WebSockets and propagating the back pressure to the WebSockets. It was very ugly, but it worked.
But there is a spec. There's a streams API.
But if there is a new spec, I haven't heard about it. I know there is the RSocket, which
maybe the spec is based on your article, and you don't know about it. Yeah.
There is the RSocket, and it's also I think it can work over the WebSocket. So it's kind of alternative. So you can connect on both sides. You can connect reactive streams to it, and it will propagate it over the network over various protocols, and you can choose one of them to be a WebSocket. But I haven't heard about the WebSocket streams.
It comes from JavaScript. I will give you in the chat. If you search for WebSocket streams or streams API in JavaScript, you will find this, and it's getting more and more popular. So I thought, Helidon could implement this, so I was immediately interested, because Helidon could be a really interesting server for the front ends, because now what you can do with WebSocket streams, you can stream HTML from the backend to the client. So I was just curious whether whether you know about that. So but just take a look at this. It is really interesting spec.
I will definitely.
Yeah.
I know there is a stomp protocol over the WebSockets. Mm-hmm. It's not that new, but it's also like everyone is trying to move to the WebSocket for some reason lately.
Yeah, because it's asynchronous, and it works well with front ends.
And it works in both ways. On the other way, there is HTTP2. Which also you have the flow control there, so you can propagate the back pressure, and it's bidirectional in the end.
But HTTP2 is not
much faster.
But HTTP you cannot use in browser like WebSockets for push, right? So if the browser gets the first request has to be made by the browser, then you can push some data to the cache. But you cannot use it in browser as a WebSocket, right? Or it was not possible in the past, at least.
There was a server push in the HTTP2. It's just not being implemented by anyone,
this is the problem.
It's in the spec, but nobody implemented, because it's kind of like overcomplicated and nobody actually uses it. And I think they had support in the Chrome, and they have been removing it.
Exactly. So I know, but I'm not interested in specifications which are not implemented, right? So it's really really hard to use. What happened actually? Why we are talking? Because I was approached by a publisher and about Helidon book. It's like, a Helidon book is interesting, right? So and take a look, and just found you, and I just pinged you immediately as we have to talk, because you were 2 years ago the last time we saw each other. But Dimitri is also writing on the book, I think. And the publisher did the usual thing. They ping me and say, we send you a book. It's like, no, I like to buy my books, not interested. But we have to talk, right? So this is now my promotion. So what is the book about, Helidon? Is the book ready already?
No, it's in early access on Manning. They have the program like that you are writing the book, and as you publish the chapters in some batches, they are publishing it, on the fly, and readers can actually buy the book and get the chapters as they are being made, which is kind of interesting. I didn't even knew the process like this exists.
Streaming almost, right? So the
like
pages are streamed to you.
Yeah.
Exactly.
So we are now streaming the book. We have the 3 chapters published, and some of others finished to be published soon, and a lot of other chapters in the making. So we are working on a book. It's kind of it's a first book for me, so it's really interesting experience. But it's kind of nice because you are looking at the thing from completely different angle. And even when I wrote the chapters about the features I didn't actually work on, it was really interesting because I finally understood the internals I didn't know about. So it's great learning opportunity to write a book. Actually, it's really nice to experience.
because you are forced, or you are forced again to think what you did and just more clearly express it. And as I was on the road, I wrote the books back then. Then for me, it was the challenge to write it as short as possible. So I wanted, to write a thin book. And this is even worse because, this is like, redundant. So make it shorter.
So, we also got limit for the number of the chapters. And we already had to like agree. Okay, there is like a third of the book we would like to write.
So Dimitri wanted to have 30 chapters about Jason B. I guess, right? Dimitri is like, okay, no,
not like there are a lot of interesting parts you can write about Helidon, but it just don't fit into one book. So we are trying to make it like somewhere in between the beginner and the intermediate Helidon programmer. So you can start with the Helidon, and you can also learn something new even if you are working with the Helidon. So we are trying to hide some gems inside which are not like usually accessible in the documentation, because it's not something you necessarily need, but it's really nice to know how it works. So it's kind of interesting. We are trying to make it in some readable length, so it fits in the book.
Mm-hmm. You can always learn from books, I would say. I never read a book which didn't learn anything from it. So I would say it's always a good idea to read books. But what's about the chapters? So what is the agenda? What's the contents of the book? What we can expect briefly? It doesn't have to be accurate. So just
may have opened it somewhere. I just have to be careful not to publish anything which is.
I mean, this is just we had the slide from Oracle, the very first one. This is like the safe harbor on my podcast. So it was already there. So
I think there is already released chapters. Is the configuration and creating of your first app, and the next chapters will be observability, some communication between the services. That's the clients.
Cool.
Accessing the data. Then there will be resiliency with the fault tolerance, etc. And security chapter. That one is interesting. That's a lot of joy I getting there. And then there will be open API and testing the application, because the testing your app it's chapter for itself. So it's nice. There will be some short chapter about the scheduling. I expect it to at least explain how you shouldn't schedule inside the microservice, because that's what everyone wants to do.
They just don't want to do. Very interesting in a cluster.
So it will be an interesting chapter. But it's possible in Helidon, of course. It may be more usable in some IoT application of the Helidon. But we want to explain the bigger picture, why you don't want to do that. Otherwise, you will have to find some,
the problem is if you have multiple microservices running and every microservice schedules, then we have too much. The frequency of the schedulers.
Yeah, you would have to elect the leader, and for that you need some steady point in the universe of your microservices, and that's always a problem. And it always was in the clusters. So we have been doing this in the web spheres, and it was same. How to say it politely? Problem.
The same challenge. I mean, this is the problem. Is you need to know a singleton, which is highly available singleton in the cloud. So this is what you need. And if you have your Helidons, they have to agree, which is hard enough in highly, But this is like general problem. But interesting. So what's another question? So you use virtual threads from Java 19. Are you using other interesting, cutting edge Java, JEPs, or APIs in Helidon? You see.
So it's interesting from the point of the user of the Helidon.
Yeah, whatever. I'm curious. Whether you are
We have the minimal version for the Java in Helidon 3, which was released, like fully released lately. There is Java 17, so we are using a lot of the language sugar there. It's just the Java it's much more fun now to do because
Yes.
you have a lot of new features. Of course, I really like the how it's called, the
Code blocks.
Code blocks. Yeah.
Yeah.
That's really
Yeah.
something I was waiting for, and not in the production code necessarily,
Testing,
but
right?
in
JSON
the
testing,
test,
right?
It's just super cool.
Yeah. Yeah, and what I also use a lot is not just the code blocks. I use also a single line that was formatted is also cool. So if you have a template, you can have a string and know the $S and $D or whatever, and it just dot formatted. The other way around was string dot format, which was static method, and the formatted is a little bit nicer. So small things like this are cool.
Yeah.
Then I work with JSON-B a lot and JSON-P. JSON-P. This is, and then even the instance pattern is interesting in Java 17 because you can say, is the JSON value a JSON string? Then I can immediately cast it in instance of. So there are small things which are really helpful. Yeah, agreed. So I'm also working with Java 17 right now. And some of my toy projects are moving to Java 19 already. And really, really appreciate it. So yeah, Java all the...
And everything is getting faster with each version. It's just magical.
Yeah, it was always fast, I have to say. So the entire discussion with Java, for me was never a problem. If I was in performance, had performance issues, it was always the database, and not even the database from the performance perspective, more like logging perspective. So there were some logs deep in the database, and this was the problem.
You can use messaging for working with the database. We have a nice connector for that.
RDBC, you mean?
No, we have Oracle AQ connector. It works over JMS. So actually, you connect to your database over JMS, and we have adapter for the.
That's interesting. Talk about this. So that's interesting because this advanced queue from Oracle is an old concept. So I used that, but back then it was proprietary. So it was not that easy to talk to this via JMS. Back then, so you need the Oracle applications.
You need the database driver from the Oracle.
Sure,
but it implements the JMS, and we are using that for the reactive messaging. So
you are saying the new JDBC driver from Oracle implement JMS?
I think it's a different library in between.
Okay, okay, because this would be a surprise. Like this is actually cool.
No, but there is another library which implements the JMS from the database team and which uses your data source and then you connect to the database and you can have the triggers which creates the events in the queue and then you just receive them in your reactive messaging.
Another project which only Oracle can do. You have the Oracle database. And they have the Golden Gate and they have the log miner, which creates events.
Yeah, you can.
What you could do, you can have, proprietary link to Helidon and receive all the changes in database without Debezium, without Kafka directly.
Yeah. We can do event sourcing like that. We can do that even without the Golden Gate because...
Yeah, then you can do this.
Just use triggers and also...
You can, I mean, I know that it's possible, but are you doing this?
Okay, I have an article.
You are writing lots of articles.
But it's in the making for a long time now.
Okay.
So I've been trying to compare the event sourcing with the Debezium, which is super fast and super cool. But there are other approaches when you don't have the Kafka in between and the Debezium and all the other tooling. And also with the OCI, you can use Golden Gate and connect it to we have the kind of a managed Kafka. It's called OCI streaming service.
Okay.
And so you don't have to take care about the scaling of your Kafka cluster.
No, but the Kafka, this is Kafka is nice, but sometimes you don't need Kafka. So, and if I would like to have event sourcing from database, I get usually per table a Kafka topic. And I have to set up, I have to care about data conversion. So JSON is nice, but is bloated. If you use Avro, is not as nice, but smaller. But if I would just able, to have microprofile reactive messaging with Helidon and say, hey, give me the events from a database, sometimes it could be good enough because then I could, receive directly the messages from database and stream them over the WebSockets to my client, and I'm done.
Yeah, it's possible.
Yeah, it's possible, but this is for me is as killer use case as virtual threads with Nima for me.
Yeah. So in the end, you don't have to actually, like blog with this read-write database issues.
No, it is easier
you
because
can
I
use
don't know.
database asynchronously, and it's
And it's
possible.
easier because to set up Debezium with Oracle database is not easy. I would say it's not. I mean, it's just it is easy if you know what you are doing, right? But if it comes with Helidon out of the box and you are Oracle and Oracle is Oracle and both Oracles, you can provide added value. So just saying is interesting, right?
Yeah, in the OCI, you are just click like, I don't know, 10 times, and you have provisioned database prepared with and then you execute one script, and then you have prepared the advanced queuing queues.
OCI, you mean the Oracle Cloud, right?
Yeah, Oracle
Because
Cloud.
if I hear OCI, you know what I think about is the Oracle OCI driver, Open Call Interface. You remember that?
No, not at all.
No, there is
What is it?
there are different levels of JDBC drivers, and an
Yeah.
Oracle. There's a thin, and there is an OCI driver from Oracle, Open Call Interface. I think this was the native driver. So if I talk this with Oracle people and they mention OCI, I always thinking about the JDBC drivers, not about Oracle Cloud. So this is what you tell me. OCI clicks. Why are you clicking on the driver? It's like, okay, you mean the cloud, right?
Yeah, we are so used to it now that everyone knows.
Yeah,
what the
check out.
OCI is.
This is called OCI JDBC driver, and this was actually at the beginning the fastest Oracle driver, JDBC OCI Oracle, and you will find exactly 7 features specific to JDBC OCI. You see, OCI connection pooling, and if someone mentions OCI to me, I always thinking about the driver. I give you this to the chat. So you can learn something about Oracle at the end.
We are going to the point where we need to recycle the shortcuts.
Yeah. And this is why for me, this OCI is always hard to get because this, how it's called now? Oracle Cloud und Infrastructure.
Oracle Cloud Infrastructure.
Yeah, and for me it's Open Call Interface. So it's like why they are so excited about the old JDBC driver, and this was and they are talking about the cloud. So but this is this even worse. This OCI driver comes with no specific features which are similar to messaging. So this was interesting. This conversation right now, everyone was happy, but we were talking about completely different topics, right? Cool. What I'm interested in, I don't know whether you know, is there a way to run Helidon on AWS Lambda, for instance? I saw an issue, but it somehow disappeared. I don't know whether it is implemented or not. If you don't know, it's no problem.
I know we had a colleague who was investigating that and working on it, and we have some POC, but I wasn't
Okay.
in the loop for this, so I'm not sure.
Because for your managers on managers of managers, so one of the killer use cases what I'm using right now, I'm using for instance Quarkus, and it runs on AWS Lambda without any changes. So I have my own microprofile code, and I hoped Helidon would also do the same. So I could also use Helidon in my projects, but.
I think there was some from AWS that there was some wrapper for the JAX-RS, right?
Yeah. It's
based on Jersey.
Yeah,
Even so.
yeah. It's called serverless containers in GitHub, and there is the first implementation was Jersey. So for you, it would be nothing to do, just pick it. But the interesting part, why it's really interesting, is what the AWS Lambda or Azure function as well. But I mean, Lambda was first, so this is why Lambda is like the serverless idea. They are retrieving the HTTP requests and transforming them to JSON, and this is consumed by Quarkus. And what happens then? It calls the JAX-RS internally. And the Jersey does the same. So if you go to serverless containers and look up Jersey, this is already, everything is done. So it retrieves, the HTTP event from AWS and invokes then the Jersey container. So for you, it would be not a big effort because I think it could be even a weekend project for a prototype, but it is actually huge because what we are doing, I'm actually talking about this also a conference next week, because you can pick, your old application and without Kubernetes and anything, just go straight to the cloud. And the same mechanism works on Azure Functions, and the same mechanism I know works on Oracle because I use FN Java a lot back then. And this FN Java, is actually the open source infrastructure for Oracle Functions, I think is the proper name, Oracle Functions. So just to your management, or if you have instead of writing too many articles, you could look at this, and just really interesting. But the WebSocket streams are really interesting for you, I would say, this standard, and yeah, cool. So and what about? Do you know about projects? Interesting projects you can talk about, which using Helidon or some, some.
I met few developers from the customers, usually through the bugs when I've been helping to someone. There was some Scandinavian company which was using the Helidon SE for sending really large files like gigabytes through the HTTP, and it was really interesting. And there was some in some really complicated corner case, there was some memory leak, so we have been helping them, and they are sending really huge data with the Helidon SE like that, and it was kind of a use case I didn't even expect to arrive.
Was it called SOAP messages? Was
no.
This was just fun. Okay.
But that was really interesting. That I think our managers who came up with a list of some customers which
no you don't have to talk about it. I think sometimes what I can talk about, because I know it. I was a part of the Helidon hackathon. This was the German company MicroStream, nice guys, and they integrated the MicroStream in or how to call it, serializer and persistence, in memory persistence, with Helidon, and it was really nicely done. So this is what I know about, and I can talk because I was part of the hackathon, and this is open. So this was the MicroStream and Helidon seems to be nicely integrated.
Yeah. It's a nice technology. It's doing the serialization without the Java serialization, so it's much safer than how it's been done in the Java. That's kind of interesting because with Helidon 3.0, we have introduced the security hardening for the serialization. I think it had a JEP number, and I have it somewhere here. It's 290. And you have by default disabled the Java serialization at all. You can, for some libraries, it's needed, so you can, by very complicated configuration, you can actually enable it. But it's safer if you don't. And with the MicroStream, you can do this serialization without this issue, because, as I understood it,
which JEP is it? 290?
I think 290.
90, okay.
And they are not actually invoking your constructor during the deserialization, so there is no that known issue which was with the old thing, and it's super fast, as I saw it when they've been saving some huge data. So it's really interesting.
Okay, lots of interesting features. So what else?
We have implemented LRA. That's a microprofile spec. It's a new one.
This is where we had already chat on Twitter shortly.
Yeah.
Long-running actions. You said, okay, for some, how it... I had a podcast with Goran, and he was. We talked about, and he looked at the long-running actions, and of course there was a brief conclusion that is of course the same problem like with schedulers. You need to know if you have something long-running, you need a coordinator, and this is hard to scale the coordinator. And you responded on Twitter. This is how I remember you, not the publisher. The publisher come later. This was the initial factor, It's like we have to talk about that. So very briefly, the long-running actions. What are they? So it's like a workflow engine, a small one, right?
It's a distributed transaction, as you remember it from the XA, but this is meant for the microprofiles. It's microservices, sorry, and it's implementation of the Saga pattern. So it's compensation logic. It's the transaction. It's not ACID because it doesn't have the isolation anymore, and you just can lean on your transaction manager that eventually it will compensate for you. So it will compensate if your transaction fails. It will compensate some method in some of your microservices, or it will complete. It will call different method if it completes successfully, and so on. There is more complicated stuff there. If you look at it, it's like very fancy fault tolerance. Because you have this coordinator, tell him, give me the transaction ID and start the transaction, and all the other participants in your transaction will connect to it and be part of that transaction. And if something fails, all those microservices, if they have implemented this complete or compensate methods, those methods will be called. And you can, for example, if it's typical, if you are booking some seat in the cinema, you just save in your database, this seat is booked, it's haven't been paid yet, and if the payment doesn't work out later, your database transaction is already committed.
Yeah.
It's just, there's different state there. And if the payment doesn't work out and your transaction, your LRA is being rolled back, it compensates in a way that your method, in one of your pods, it doesn't matter in which one actually, you will have a compensation logic which will clear the seat which is booked because the payment didn't.
This is instead of having one long blocking transaction on XA and relying that everyone waits until completes, we have a series of shorter transactions, and if we split the business process to actions and say, okay, if I ship something and the customer cannot pay, I would just ask the client, to send it back. So we change a little bit the business logic and make everything consistent from the business process perspective. And Goran in the latest podcast said that it is impossible. We said, okay, it's hard, to scale. And you said it's possible. It is possible, but if you are in a cloud, you need a storage somewhere, right? You need a central store to store the state of the LRA.
You need to store a transaction log.
Yeah.
And so every coordinator has a transaction log. The thing is, as there is no isolation here, those transaction logs doesn't have to know about each other if there is more of them. So if you hide the coordinators behind the load balancer, you can have multiple transaction log. And each time someone starts a new transaction, it will get back the URL of the coordinator they have been assigned to. So if you remember this direct route to the one of the load balanced coordinator, you can always call that one concrete coordinator which you got from the load balancer. And this way you can have multiple coordinators, and you can scale up, in a way that's achievable. There is a problem if your load balancer dies, you have to restart it and you have to start up from that particular transaction log. So
what you are saying in LRA that the coordinators are stateless, so the entire state is in store somewhere. Sure, this has to be the case. But I can go to any of the coordinators and I can just ping whatever coordinator I like and get the response.
With that one, once you have assigned transaction ID, you have to always get back to the one concrete coordinator on that one concrete transaction log.
But which is doable. But in the cloud, I have to set up the load balancer in proper way. The load balancer will have to.
It's kind of complicated to do it in the Kubernetes, but it's possible. It's just that no many people have been actually trying to address this issue because the transaction managers have been always like the one star in the universe, and everyone was kind of like think about it as a one thing. So with the LRA, unlike with the XA, it's possible. And you can do it. It's just complicated. And maybe we will come with some. I've been trying this approach. It's possible we already have the Oracle Transaction Manager for microservices. It's a new product. I think it's even free.
Okay.
I'm not sure now. I don't want to give a false hope to anyone. But we have this transaction manager for microservices, and that one is able actually to return you the different address if you ask for the start transaction.
So it seems like Oracle Transaction Manager has something to do with Helidon and with LRA, right?
Yeah, it works. We have some example of it. It's
Oracle Transaction Manager is the microprofile LRA implementation with Helidon, right?
Also, it does more. It's a coordinator implementation for the LRA, but it also does XA and.
But this is Helidon is used behind the scenes, right? For that.
No.
Okay,
It's,
I thought
I think it's written in Go or something.
Go at Oracle. Oh.
Yeah, we are.
Why are you using so old technology? I thought you're using modern Java at Oracle, not technology from 1945.
We do, but I think it's. I haven't. I have. I'm not part of that.
Yeah,
team.
this is
much
your
about development
luck.
process.
Yeah.
Yeah, but I heard somewhere it's a Go, and
Yeah, nobody's
I
perfect,
think
not even Oracle.
that team is the original Tuxedo team. If you heard about them.
Yeah,
So
okay, cool.
they are very confident with their transaction skills.
Yeah, no, you are right. Tuxedo was lots of C++, so it makes sense Go. So there was like old C++
right.
shop. There's a low level. Tuxedo was like the transaction manager, which was bought by BA, right? And then Tuxedo, and exactly. So TUXedo. Okay, cool. Maybe the context is important. So from my perspective, so I have two architectural modes. So usually I'm working, for clients, architect or whatever. So a business project. It's not like I'm implementing Helidon like you. So I have to to go to clients and suggest something, right? So, and if you are on premise, so on premise means I have my own data center, then something like LRA is perfect. So I can just use it and I can do whatever I like, and it's worth use it. If I go to the cloud, I wouldn't use LRA. What I would use instead is like some kind of, how to call it, already provisioned, managed, proprietary cloud service. You know what I mean? Because I don't like to bother with all the load balancers on this, because I'm already in the cloud. I would like something to use what's already there. So this is the different architectures. What I never did and never do try to avoid is to pick my on-premise setup and go with it to the cloud. Because
right.
so
it's like installing Kafka in the cloud. It's
I would use. I wouldn't like to use my own Kafka in the cloud. I would like to click something existing. So Oracle's Kafka manage or whatever. I don't care. I would like to have a solution which is provided by the cloud provider. This is the entire point of having the cloud. For me, it's not like, instead of running my machine locally, I run it in the cloud. This I don't believe at all. This is like, everything gets complicated. But if I get the entire setup in the cloud, so this is what I expect, as you said, maybe if there is an implementation like Oracle Transaction Manager and it runs already in the cloud, perfect. I just use it. I don't have to care about how it stores the data. I have to believe it is working, because economy of scale, right? This Transaction Manager is already used by thousands of other clients, so I hope it has less bugs than my own solution. So this is why it's often, if you hear me talking, you have to be careful. Is he talking yet now about on-premise? What do we do if we have everything under control? Or if we buy stuff in the cloud? Because if I go to the cloud, my first idea is to buy as much as possible, because what's the point of going to the cloud if I have to build everything by myself in the cloud, right? So this is important. And with Goran, we had that talk, about serverless Java in the cloud. So in this mode of operation, I try, to use as much as possible from the cloud, and try, to avoid any possible infrastructure implementation. So like old Java E days, this is back to the roots. So we just focus on business logic and nothing else, right? So this was the discussion with Goran. So this is why we're talking right now as well.
Yeah, you can also go the other way around, and you can actually run the OCI on premise. We have some.
Yeah, this is what Oracle actually, and no kidding. This I mean, you could always run the JDBC drivers on premise. We're talking about the Oracle Cloud infrastructure, of course.
Yeah.
But what I heard actually a lot of good things about Oracle Cloud. It seems to be cheaper. There's a true free tier. And this on-premise is also a feature. So like Oracle is open, to as like that they seem, to be really eager to install the entire infrastructure on-premise. So good stuff, I would say. So
it works. We have some customers who already like having that in production, and it works. And it's like it's even hard to imagine for me how the cloud guys are doing that, but it's possible.
Yeah. And there was one project which I also used a lot. This is FN Java, which is the it's still open source. If you search for FN Java, you will find it. And this is
that's what the OCI functions are based on.
OCI functions, actually. OCI functions, which is you can actually, this Java code is executed for you. It's very similar to AWS Lambda. There are also no hot functions, so that you can avoid cold starts. So it's actually a really nice project. So this is about OCI, and you can use JDBC drivers on OCI. Should also work. So what else you can tell us about Helidon? Are we done, Daniel?
We are neck deep in the NEMA right now, so we are playing a lot with how to do stuff as most efficiently as it possible. It's very hard for me because I've been like really into the reactive stuff before, so it's really hard for me to switch from this thinking of and then you just block here until something happens, and it's something. So it's still hard for me. It's still like when I'm thinking about stuff, I'm still getting into those. Okay, I think I have a solution, and then I realize, okay, I don't have to do all of that at all because there is no callbacks and anything. You just block, and the JVM will do that for you. It will just multiplex the threads for you, and you don't have to.
This is why you're writing books and articles, because there is nothing else to do for you, right? So you just write simple code, a 2-liner, and say, okay, everything is done. Back then I had to write 2,000 reactive code lines of code of reactivity, and now 2 lines of code, and you are done, and you have lots of time to writing articles and books, right?
Now we are also adding new features into the Helidon, of course. We have, for example, this is a nice thing. We have this modular routing in the Helidon 3. It's because we already have it in the NEMA prepared, so we have kind of backported the API to the Helidon 3 into the reactive one. It's very differently implemented, but in the end you have the routes. You can have the same endpoint, which have different handlers for different protocols. So you can have a handler for HTTP1, and you can have a handler for HTTP2, and then you can have a handler for WebSockets, and it's all on the same endpoint, and you can and those will be invoked depending on which version of on which protocol you intercept it. So it's kind of interesting, and even nicer thing about it is that it's got modular, so support for the HTTP2 is a standalone jar. So you don't need it. If you are not planning to use HTTP2, you don't need it. So your Helidon app will be smaller because you just don't use the WebSockets and HTTP2. And if you do, you just add one dependency, and then you have support for HTTP2, and you can create the routes. There are some implicit routes which are, for HTTP, you can have it will take care of both of them, and your handler will work for HTTP1 and for HTTP2, and or you can have another for the WebSockets and so on. So WebSockets is the same story. You have just standalone jar, and you just add the dependency, and then you can add routes for the WebSockets. We have a Tyrus mounted on top of that, I think. But
okay, Tyrus was the reference implementation of WebSockets, right? It was the exactly.
Yeah, it is.
That's interesting. So it's like the Helidon is like a small, reference implementation. You're reusing lots of the Glassfish stuff, and the technologies like Tyrus and Jaxores, and
we are reusing some developers from Glassfish.
Yeah,
that's for sure. so
which
so
is
you can
good.
say that. But the Glassfish was mounted together from more projects, mostly from Jersey, and the Jersey team is actually part of our team. So the Jersey is being made also in the Dmitri's teams here in Prague. It's Jan Šupol is overseeing it right now, and so we are like sitting next to each other, and we know each other well. So the integration with Jersey is always like very tight.
Yeah, that very good news, because Jersey is a lightweight framework. It can be run from Java SE. You don't even need to know Glassfish to run Jersey. It's
lightweight, and it has a lot of features. So the project itself isn't that lightweight. If you try to check it out and contribute something, for example, you will have to build it for a long time because there is a lot of features there. But those features which are there are really battle proven, and they are written by very clever people. So it works in the Java 8, so it's really backward compatible, and so on. So and it's as main entry point where the Jersey actually is taking the data from the server. It's actually the input stream. So in the end, with the Helidon NEMA, it will be again the input stream, which will be cool again because it's blocks and nobody cares anymore. So we will get back to the input streams, and it will kind of fit together all nicely with the NEMA, and we'll be back in those years when we didn't know about any reactive stuff.
What I did recently, I just was curious and fire up the Helidon CLI again, and really nice experience. So I just Helidon CLI, I got asked a couple of questions. Would I like to have a microservice as a microprofile microservice? Say yes, and I got a working solution in no time. So I got to know the JAX-RS, and I even recorded a short screencast about that because it was a nice experience, and it started at in 1 second or whatever. So so it was a nice experience. So looks really good. So
it's super fast because it's a ground native image.
Not even I just use the standard JVM. I mean the Helidon, the CLI. Yeah, the Helidon, the CLI was I just downloaded the binary and
and the binary that's a Java application with compiled with GraalVM native image. It's super fast. We are still making it better. So I've been creating some courses for Oracle University, and we have been using the CLI there. So it has even the batch mode, so you can have like the one command, in some tutorial, and it will just generate exactly the project with exactly the features you want. So it's nice. It has the same. It's in the backend. It does the same thing as the Helidon Starter, which is a web page when you can click which features you want, and it will generate a project for you. So it works in very same way that it will generate this project for you, and you can work. It has a live reload, which is also a nice feature. So if you are working in some with some smaller example, you can. It detects the changes in the files, and it will reload the whole app. And because Helidon starts really fast, it's almost unnoticeable, and you can see immediately the changes you made in the code.
Okay, very good. So it was nice to meet you again. So our bi-yearly meeting and updates. And let's see what happens the next 2 years. So we have to remember now the discussion now. This was and then see what happens. So where people can find you? Helidon.io is the website from Helidon, right?
Helidon.io. And with the GitHub, there is a big news. We have moved from different organization, from the Oracle to the Helidon IO organization. So
so Helidon is now bigger than Oracle became, right? So you you outgrew the Oracle business.
I would rather not say that, but it's we want to make clear that the Helidon is open source project.
Yeah,
it's just backed by the Oracle, so there are Oracle employees working on it, but anyone else can help, and we have a lot of outside contributors. So it is open source, and we wanted to make it like having our own organization are making better structure, because there are some other projects now, and it's the Helidon is getting more.
Yeah, I can confirm it. The Helidon looks really nice. The website looks really fresh and nice, and it is true open source project. And even if some, it's Oracle of course back projects, but with some Sun Spirit inside, even the Jersey and whatever, it comes from the Sun Microsystems roots. So as I would say, remembers me really about the Glassfish days, where I don't know. Remember the Glassfish 3 was one of the first servers with the long polling with the Grizzly, Grizzly integration, which was highly scalable server. This was nothing comparable back then, so it was better than Tomkin and anything else. And now we get the same with Helidon and virtual threads, which is great news. So the same revolution actually happens again.
Yeah, when you are talking about that page, that most of it was done by one of the used to be Glassfish developers. So
Yeah. Yeah. And where people can find you on Twitter?
yeah, I have a Daniel Katz altogether,
Yeah.
which is my handle, and same goes for the GitHub and LinkedIn and everything else.
So thank you. It was a pleasure. Lots of fun talking to you.
Yeah, same here. Nice to hear you.
Bye.
Bye.